Next up, random access memory, RAM. RAM is pretty much the same as the stack, except now instead of have it, so what a pointer is, so this is a pointer here, it uses a number in your register and you use that as an address. So instead of having an immediate where the programmer just puts in a number, I just use a number that's already in the registers as an address. Ooh, I should actually do this. I should be able to take the stack, peek the stack, and load it into the RAM. That'd be awesome. Okay. So yeah. So what this does, so let's say if I want to store something to the stack, I would put this as a 1, and I would take whatever. Oh, load star. Okay, yeah. I would put whatever source I want, and I'd also have to put a pointer for an address, or else it'll just do a 0. So if I leave this as nothing, it'll load 0 because the 0 register always has a 0 no matter what. So it'll just load a 0. So let's say register 2. It'll take the contents of this register, use this as an address, and stores that to RAM. But if I wanted to load something out of RAM, I'd use a pointer. So let's just keep it the same, and then I'd put a destination. Boom. Just now I just added this, so I'm gonna, since I have 1 bit, I'm gonna just do like this. So if I'm gonna use a stack, that means it's gonna peek off the top, store it to RAM. If I'm gonna load it, it's gonna put, okay, so I'm just gonna put this sign as use stack. So that's that. So then next up is PSL, port store load. Let's look at this thing here. Where's port conditions? Okay, so right here I've got 3-bit for conditions to access the ports. So what this will do is, you can see here, this will load store for all the different ports, and these are what the ports are. So the first port is for a keyboard, second is for a screen, network is, yeah, it's for a network, but most likely will not be connected to a network because networks are fucking hard to do well in Minecraft anyway. You have to load chunks and all that weird shit. And the fourth port is unspecified. So let's look at this weird fuckery. So for the ports, you can load a 16-bit number to the ports, but you can only store in 8-bit numbers to your registers. So what I can do is, depending on the condition, I can use this as a source and use this as a source. So let's just do that. And now would load these 2 registers. But if I wanted to store, I would just use this address. So that's that. MCF and MOF, those are monitor functions. Those monitor the carrier flag, or in this case it'll monitor the if0 flag. And so how that works is, it'll set a target register. So let's say if I set my target register as register 1 for both instances, what that will do is check whenever these registers are written to, it will check the conditions that were generated or from the ALU. So if the caret flag is true while register 1 is being written to, or if it's the if0 flag, that will then branch to whatever location you have here. So that is hella fucking useful, because instead of having to do multiple checks between each line, so let's say if I do Fibonacci, I need to add, then check it if there's a carry out, then add, check, add, check, add, check, and once there's a carry out, it'll stop the function, because the CPU isn't CPU is only 8 bits. Well, it's only a finite amount of bits, and it'll eventually carry out. So instead of having to do add, check, I can do monitor, add, and then whenever the condition comes up, it'll branch. So if you think about it, in a loop, instead of having to do add, check, I can do check once. So the loop's going to be twice as small, effectively. So next up is CNR. CNR is call and return. Call and return, all you're doing is branching to a location while remembering the location you branch from +1. So let's say if I was on line 0 and I did a call function and I chose an address, this address, I would branch while this function would remember that my line was 0 +1, so it's 1. So it'll remember 1. And once I want to return back to where I was previously, I would just put this as a 1, and it would branch to line 1. So it just remembers where you were, +1, and yeah. So effectively it's just a normal jump, but remembering. I think it's called jump and link in other cases, I think it's called jump and link. Oh well. OFS, offset. All this does is, so in an adder, not in an adder, in a program counter, it just goes this line, then the next, so it does +1 each time it goes across. So instead, I can add something called an offset. We will offset the number. So let's say if I selected an offset of 5, instead of going 0, 1, 2, 3, 4, 5, it'll do 0, 5. Actually, no, it'll do 5. Basically, it'll do 0 + 5, which is 5. 1 + 5, 6. 2 + 5, 7. So you can see that pattern. It'll just add that each time. So instead of doing 1, which is standard, it'll just do whatever number you specify. So I can either choose from 0 to, actually I'm gonna make sure that you can't do 0 because that's fucking stupid. So instead I'm just gonna make it just do 1. If there's only 0 here, I'll just automatically make it into a 1, but I don't know why a programmer would do that. It'd be fucking stupid. But yeah, you can either use a register or you can use an immediate. So if I want to have 1 as my offset, all I do is this. Or if I wanted a register, I'd do that. Simple. Relative jump. Relative jump is a way of jumping without knowing where you are. So let's say if I was on register 2 million something. Instead of knowing that big ass number, I can do jump relative to where I am +3. So it'll check where you are and it'll just add 3 to wherever you was. Or it can minus. So yeah. So it just jumps relative to where you are. You'd have to have an address, it's just relative. So that's pretty cool. So for that you can also use a register or an immediate. CMP, compare. Compare, all that is doing is comparing two numbers using subtraction, and it takes the conditions generated from this, and then that will be used in these branches right here. So all that does is uses two sources and doesn't return any value. It just returns the conditions. That's all. That's it. So so down here. So first off, this jump. This is an unconditional thing. Jump, branch, whatever you call it. So jump just takes your pointer or your address and jumps to it. It doesn't care about any conditions or anything like that. Next up is branch if 0, branch if carryout, branch if equal, branch if greater than, branch if less than, and then there's branch extensions, but we'll worry about that last. All these do, it takes the flags that have been, the conditions that have been generated here, and then checks whether they're true, and if they're true, they will branch. If it's not true, it'll just keep trotting along. So branch extensions. Currently, there's only 2 extra branches, but I can add any that I want. I can add 5 more. Yeah. So currently there's only 1 bit, and these equate to this. So if I want to branch from the barrel shifter carryout, or the right shifter underflow. So yeah, so that's useful. So I can add more later, but for now those are the only ones I have. So all those do is, instead of doing a compare, because I don't want to do a compare function just for these, all that will do is look at the previous conditions used by these, and then it will branch if those are true. So this is where no-op comes in handy, because let's say if I do branch extension if barrel shift carryout. Now, because if I do a barrel shift at the one cycle after I've set the branch, that could change the condition, and that would fuck up the branching. So that's why I would use a no-op instead. But yeah, I think that is it. This took so fucking long to do, and I did it before my hardware. No, after my hardware. Actually, half of my hardware. Yeah, I made some stuff, but then I made this in between. The reason why I did that is actually because fuck you. Spelling. The reason why I did that is because I usually know my hardware before I've even done my instruction set. So let's say if ALU. So let's say my ALU, I always know that you're gonna need an ALU regardless of your instruction set. I know that you're gonna need registers regardless of your instruction set. So yeah, so that's why. So yeah, that's pretty much it. Hope you enjoyed. If you don't understand any of the operations, just ask in the comment section. And yeah, like, subscribe, do whatever the fuck you want. Peace.
Never ever find the right words, and there's no way this is real life. There's no telling you're the right girl, so I can only say that it feels right.